So welcome. Thanks for being here, everyone. This is the second of 5 consecutive Fridays in which we're having sessions about activities through which students can explore statistical concepts. Today's presenter is Karen McGoy, a colleague here at Cal Poly, a professor of statistics here at Cal Poly. Karen's also been very involved in the AP Statistics program, including recently as chair of the Test Development Committee for AP Statistics. Karen's going to be presenting one or perhaps two activities on the topic of variability and sources of variability. So please take it away, Karen.
Okay, hi everybody. Thank you for being here. Let's see if I can share my screen here. Get going.
Looks good.
All right. So as Alan said, I'm going to talk about sources of variation and explaining variability. This is in large part motivated by the ASA GAISE guidelines and even the college revision that's coming. One of the 10 recommendations is to encourage multivariable thinking. It's not 100% clear where that might happen in the draft learning objectives, but I've circled a few places where we might be able to think about multivariable thinking sort of in the context that I'm going to talk about it today. Obviously, some of those other learning objectives deal with multivariable thinking as well. So as Alan mentioned, I'm going to talk about and work with you on two activities today. The first activity is just explaining variation in a quantitative response and getting students to think about variability maybe a little bit differently than they have in the past. We'll use an observational data set from the 2020 US Census on income. And then activity 2 will really be a more hands-on activity with you all. I'm going to put you in the role of student. We're going to collect some data from you and use that to think about the purpose of random assignment. So activity 1, again, uses data from a random sample of 10,000 cases from the 2020 US Census. The response variable that we're going to look at is yearly income. I've done some data cleaning. I've removed people who were not employed and or had an income reported as 0 or NA. And so the sample size here then is 4,365 individuals. For the students, probably an understanding of univariate summary statistics and graphs would be helpful at this point. You could certainly do this sort of as you're teaching these things, but it might be a really nice follow-up exercise once you've talked about measures of center and spread. The activity itself is located in a Google Doc. And so maybe I can try to chat that, or maybe Alan can do it. Yeah.
Yes, I can do that.
Okay, cool. So my slides are going to mirror what's in the chat or what's in the Google Doc. So I would start this activity by just showing students a graph of the yearly incomes and some summary statistics. And then we might, ask what's a typical yearly income for these people, hoping that, they'll talk about the mean and the median. Maybe because the distribution is skewed, we might focus a little bit more on the median salary. And then where I really want to get to quickly is this question: do the yearly incomes of these 4,365 people vary? And so looking for students to be nodding their heads and then asking how we know, right? And so if they've not been introduced to the IQR or the standard deviation yet, an answer which just says, well, when I look at the graph, the salaries look different, right? But students who have seen standard deviation in IQR might go ahead and cite those statistics. And then a follow-up question, what would the values of the standard deviation and the IQR be if there was actually no variability in yearly income for these 4,000 people? And so that's, I think, a pretty straightforward question. The students, should respond with 0. But this question maybe is a little bit more difficult. What would the values of the mean, median, Q1, Q3, minimum, and maximum yearly incomes be if there was no variability in the yearly incomes, right? And so often students will say 0 for that. So want to have a conversation, that, well, they would still have a yearly income, right? But those values ought to be the same. And then what would the histogram of yearly incomes look like if there was no variability in that variable? And so hoping that students can sort of think, well, the graph ought to look like this. Everybody ought to have the same value for their yearly income. So clearly we're dealing with a situation, right, where incomes vary. It's not reasonable to think about everybody having the same yearly income. So then what do you think are some possible causes or reasons or potential sources of the variability in the yearly incomes of these 4,365 people? So if you have some ideas, maybe put those into the chat, right? So what are some reasons or causes for the variability that we see in yearly income? All right, so here, trying to get the students into the context of the data, and right, think about not just that there is variability, but what's causing that variability. Yeah, so looking at the chat, how long they've been working, their type of job, where they live, education, lots of things, right? This is pretty accessible for students. So then, right, let's take one of those sources of variability that they came up with. So for example, education, and let's categorize the yearly incomes by education level, right? So I've provided some summary statistics and broken out these people according to 5 different education levels. And then ask the students, does it look like there's a relationship or an association between yearly income and education level, right? And so I would want them to provide some explanation of their thinking with numerical supports, right? So citing the means or the medians and the fact that those differ, and that as education level sort of increases, so do the means and medians. Right. And then the next question, does it appear that education level is responsible for or explains at least some of the variability in those yearly incomes? So this is a harder question. What do we mean by education level is responsible for or explains at least some of the variability? So what would you point to for this question, right? What would we look at to think about whether education level explains some of the variability? And maybe to sort of give you a reference, here's the original data before we broke it out by education level. And I've circled the standard deviation there. It's about 68,338. All right. So I would want my students to sort of focus on those standard deviations maybe, right? And say, well, after we account for education level, right, the leftover variation in yearly income is generally less than the overall standard deviation. So certainly in one of the groups, the master's degree, the variation is actually much bigger. But kind of in general for these other 4 education levels, the standard deviation inside that education level group goes down, right? Which is sort of an indicator that, yeah, this variable might be explaining at least some variability in those yearly incomes, right? So then maybe some more difficult questions. If education level was not responsible for any variability, or maybe only responsible for very little of the variability in yearly incomes, what would be true of those 5 box plots relative to each other, right? So I encourage you to think about that for a minute. So students a lot of times kind of want to do this, right? They want to think about the fact that, well, that would mean there's not any variability inside those education groups, right? But that's not really what we're talking about here, right? We're talking more about this sort of situation, right? Where the means and medians of those different education levels ought to be about the same. And so all the variability that we saw originally in the data, right, is still there, right? We're still seeing variation inside the education groups. It's just that there's very little difference in kind of the typical yearly salary between or among those 5 education groups. Another follow-up question, does education level explain all of the variability in those yearly incomes? Right, so right here, recognizing that no, that's not the case, right? And if it did, if education level did explain all of the variability, right, then those standard deviations inside the education levels would be 0, right? Because there would be no variation in yearly income left after we account for the education level. Right. So then kind of circling back, right, to get students to think about, okay, so education level explains some, but not all. There's still variation left after we account for education level. So what are some potential sources or reasons for that leftover variability in yearly incomes, right? So we can go back to our original list. Those things that we have not yet accounted for ought to be responsible for some of this remaining variability, right? So I went back to the full data set, 4,365 yearly incomes, and then categorized those by region of the United States. Asking the same question again now, does region explain at least some of the variability in those yearly incomes? Right. So again, wanting students to kind of focus on really sort of 2 things, that the means and medians sort of differ among those regions. And then, right, this is sort of smaller standard deviations inside at least some of those groups, right? So in the Midwest and the South, the standard deviation or the leftover variability is smaller than that original overall standard deviation. Again, does region of the US explain all of the variability? No, right? Again, because we still have variation left after we account for the region of the country, right? And so finally, trying to get here, right? So which variable, education level or region of the United States, do you think explains more of the variation in the yearly incomes of these people, right? So now sort of looking at these side by side and wanting at this point for students to land on education level because there's less leftover variability in most of these groups anyway, after we account for education, compared to what happens after we account for region of the country, right? And so this is a really simple exercise that you can do, really early on in your Stat 1 course. I tend to teach a lot of the second course in statistics, and this is kind of where I start my students, because I eventually want to get here where we look at the analysis of variance. And I'm showing this to you all also, right, so that you can see, right, that the leftover variability is captured by the root mean square error statistic when we run an analysis of variance. And that's how that is computed. I'll show you that talk about that in a minute. But here's the original data. The overall standard deviation of the data is $68,000. After we account for education level, the leftover variation is about 64,000. After we account for region of the country, it's about 67,800, right? So education is in fact explaining more variability, right? And remember, R squared is the proportion of variability explained by the model. And so education level here explains about 11% of the variability, while region only explains about 1.5%. So I don't think you need to go here if you're in a stat one class, obviously. But just so everybody here is on the same page with this. And then just a reminder that the root mean square error is sort of the average of the group variances after we take the square root. We weight by the sample size, and so I've sort of adjusted the computation by the sample size here. But if you were to go through this math, then you would end up with the root mean square error for education. So my stat 2 students, I would expect to have some kind of understanding of that, but certainly not a stat 1 student. So that's just kind of and maybe again for a stat 1 audience, kind of a nice summary discussion, maybe showing the benefit of really understanding measures of center and standard deviation. Nice in that we're able to compare a couple of different ways to break down the same data by education level and region of the country. And I think this data set is available on the eStars website that we can give maybe in the chat or after the talk is over. So, okay, so I'm going to stop there with that activity, and I'm going to get now into a second activity, which is maybe a little bit further into the course. I'm going to talk about random assignment and why it's important, what the purpose of random assignment is. So you can sort of do this when you were introducing designed experiments, have the opportunity to collect some data from your students. In this little activity, each student is going to be randomly assigned to a sequence of 30 letters, and they'll be given 20 seconds to memorize as many of those letters as they can in order from left to right. So here's an example of what a sequence might look like. This would have 30 letters in it. And for 20 seconds, the student is just going to try to, memorize those letters in order. Okay. So I'm going to have you play the role of a student here shortly so that we can collect some data and have that to work with. After the 20 seconds, the students will type in the letters that they remember, and then we'll record each student's memory score, which will be the number of letters that they remember correctly in order. Okay. And then there's also 2 follow-up questions. Each student will be asked whether they've had any caffeine today, and then also how much sleep they got the previous night. Okay. So I would start this exercise with a motivational video, and I'll show you a little clip of this here. So let me get out of the screen and see if I can stop sharing and go to a different share. Stop. All right, hang on, it's coming. All right, so I'll just play a few seconds of this.
This is Jonas von Essen, a student at Chalmers University of Technology, Sweden, and a two-time world champion in memory. He can memorize 26 decks of cards in an hour and recite pi to over 50,000 places. Most of us can probably remember 3.14, but what comes after that?
Pi is roughly equal to 3.141592653589799.
So, how does he?
Okay, so to get students sort of into this activity, right, I would show this whole video. It's only 4 minutes long, and it talks a lot about visualizing when you're trying to memorize things. And so once they've seen that, sorry. Oh, okay, yeah, here we go. So then I would give them a link to a web page. So I'm going to give you this link in just a moment. At the beginning of this web page, when you follow the link, you're going to see these instructions. Press start to display a sequence of letters and start the timer. You're going to be given 20 seconds to memorize the sequence. After the time is up, the sequence will disappear and you'll need to type what you remember in the input box. And so this is the input box. So you'll just type in the letters that you can remember. You don't have to worry about dashes and spaces or capital letters versus lowercase. Just type what you remember. And then the web page will ask you the 2 follow-up questions on caffeine and sleep. And then you'll submit your data, and that will populate a Google Sheet, as well as a couple of applets that we will, well, we'll look at one of those applets, okay? So I would love for you all to participate in this, but obviously if you don't want to, that's fine. So let me give you the link. And I'm going to stop sharing. And so I'm going to chat this link into the little chat window. And so once you find the link, then follow that link and press start and begin the exercise. So you guys are the eStars workshop. I'll give folks another 20 seconds or so. Okay, so let me share again. PowerPoint. Okay, so maybe Alan, you can chat the link to the Google Doc of activity 2 if you want. So just like with activity 1, I'm going to sort of walk you through activity 2 once we've sort of collected the data. So maybe one of the first questions I would ask is, after the students have done what you did, for what variables did each of our students provide information, right? And so I would hope that they could tell me, well, I gave you information on caffeine, I gave you information on my memory score, I gave you information on how much sleep I got. The one that they might not know that they've actually given us information on is the sequence that they were given. And what you may not realize at this point is that there are, in fact, 2 different sequences. So the main goal of this study is to investigate how the type of sequence, which for us is the way the letters are chunked or grouped, affects memory score. So this is kind of what we're trying to get at, right? So how is memory score related to the type of sequence? Here's at least the first few letters of the 2 sequences. So one of the sequences was easily recognizable acronyms: FBI, OMG, CIA. The other sequence was the same letters in the exact same order, but they were chunked differently. So FBIO, MGC, IAU, etc. Right? So the idea is that, maybe the one with the easily recognizable acronyms is going to be easier for people to remember. Okay. So before we look at the data, though, right, I would want students to think about, will each student have the exact same memory score? No, right? And if they don't, what are some potential sources of variability in those memory scores, right? So if you want to chat again, what are some things that you would reasonably believe might be causing variability in memory scores? Yeah, so things like age, distractions, fatigue, level of commitment, stress. Okay. Good. All those are great. I would also hope that they would say, well, you asked me about caffeine, so maybe you're thinking caffeine might have something to do with how well I can remember things. And you also asked me about sleep, so maybe sleep might have something to do with those memory scores, right? So kind of as an aside, I've got those 2 circled here, right? So I think this is a discussion to have with students, right? So how would caffeine consumption, which was just yes or no, be a source of variability in memory scores, right? So how does consuming caffeine or not change memory scores, right? And so I would want students to say, well, maybe people who have had caffeine, they're more awake, and so they might be able to memorize better or more letters, regardless of the sequence they had, right? than people who haven't had any caffeine, right? Or vice versa. It doesn't really matter what direction they argue it. But just that differences in caffeine consumption, yes versus no, are potentially at least could cause some variation in those memory scores, right? And then what about the amount of sleep? Could that be a source of variability in memory scores, right? And if so, how? Right. And so again, wanting students to think about, well, if I've gotten more sleep, I'm not tired, I may be better able to focus. And so I might have higher memory score. Okay. So sort of continuing down this path, right? What about something like student age, right? Is student age likely to be responsible for much variation in memory scores? And so this is something that I would hope students would say, well, maybe not, right? Because we're all about the same age. Okay. Now you may have some non-traditional students in the room. And so, there may be a rich discussion there that we're not all the same age. So, something to consider there with student age. And then what about the conditions of the experiment? Right? So are the conditions under which the data were collected likely to be causing much variation in memory scores? Right? And so here, I would hope that students would say no, right? Because we sort of all did it the same way, right? You gave us the web page, we went to the link, we pressed start, we spent the same amount of time, that sort of thing. So, both thinking about things that may in fact cause variation and then variables that may not. And then what we try to do is to get the students to organize all of those sources of variability into what we call a sources of variation diagram or table. And so, right, wanting students to recognize that our response variable is memory score. The goal of the study here really is to investigate how the type of sequence affects memory score. So we're going to call that a source of explained variation. And then all those other sources that we brainstormed kind of get lumped into this sources of unexplained variation category, right? And then we have things like age, major, if your class is, has common majors in it. At Cal Poly, we have a class for biology majors, we have a class for engineers, statistics class for biology majors, for engineers, for business, right? So if I'm teaching to business majors, right, then maybe one of my inclusion criteria is the major of the student. And then, right, things that were held constant by design, which hopefully in this case is the data collection. We all did it at the same time of day, the same web page, the way memory score was determined, the number of letters were counted until your first mistake, that sort of thing was all held constant by design. And so these things over here on the left, right, we're sort of saying, well, those are likely not causing variation in our responsive memory score. Although, right, we could have a little bit of a discussion about inclusion criteria, right? If you do have differences in age, right, even if age is an inclusion criteria, that may still cause some variation, right? But having a tighter range of age is likely to cause less variability than if we had a broad range, right? With something like memory, anyway. So the inclusion criteria give us our scope of inference at the end when we're trying to draw conclusions, like who do these conclusions apply to? Who can we generalize to? And then the constant by design, I want my students to understand that those are really limitations of this study, right? So when we go out to humans in the real world, are we going to see the same results, right? Maybe not, because this was a tightly controlled experiment. And so I think it's good practice to remind them of that. And that's sometimes why we don't see things replicated in the same way, right, out in the real world. Okay, so I'm going to let you play with the data now a little bit. So I'll stop sharing. I'm going to go back to that web page that you were on. And so if you come here, can you all see the web page from my screen? Okay, so you'll see at the bottom of the page there are some links, and these will, if you follow these links, our data will load into these particular applets. And so I'm going to go to the multiple variables applet. So if you click on that applet, it should take you here, and this is the data that you all provided. Okay. Notice that the variable names don't match what's happening over here in this window. So if you'll select use data, that will bring those that data into the applet for you. Okay. So the first question that I would ask here, so let me come over to the activity, right, is I would want students to describe the distribution of memory scores. What's a typical memory score? How much variability is there in memory score? And so in this applet, if you just grab the memory score variable, you can drag it into the response box. And so that'll provide a graph. If you click show descriptives, it'll give you the average memory score, the standard deviation of memory score. It also gives you sums of squares. So if you're teaching a second course in statistics and you've talked about sums of squares, that information is down here. If you're in a first course, just have students ignore that, I guess. You can also show a box plot if you'd like. So just getting students to think about what they're seeing in terms of the data set here, right? So then the next thing I would want them to do is to, right, investigate how memory scores are related to the sequence. So in the applet, I think the simplest thing to do at the beginning is with students is to drag sequence into the subset by box here, and that will provide two graphs, one for each sequence. Okay. So now, right, we've got the mean number of letters that was correctly recalled for the FBI sequence is 9.17, and the mean for the FBIO sequence is 8.27, and we've got some standard deviations down here, right? So now we can start talking about, does it look like there's a relationship? Does it look like there's differences in the way people performed for these two different sequences? Does it look like one sequence is better than the other, right? So again, just summary statistics. We're not doing any inference here, okay? All right, and then at this point, I would kind of want to stop and ask students, do you think there's other explanations for this difference in performance between the two sequences besides the fact that people got different sequences? Okay, so, right, are there other possible reasons why this sequence has a higher mean compared to this sequence, besides the fact that the sequences were different, right? So, right, what do you think? Are there any possibilities? So maybe at this point, because I've already primed the students with caffeine and sleep, they might come back to one of those two variables, right? So I would ask, right, well, let's just consider caffeine. Explain how, whether or not a student, let me rephrase that. Explain how whether or not a student has had caffeine today could provide an alternative explanation for the difference in the mean memory score between the two groups, right? So how could differences in caffeine consumption help explain this difference in the two means? Okay, so I'm going to go back to my PowerPoint now. Maybe if I can get there. And share that. All right. Okay, so the discussion I would want to have with students at this point is that what would need to be true for caffeine to provide an alternative explanation for the observed difference in memory score between the two sequence groups, right? So I would want them to recognize, well, it's got to be having some sort of impact on memory score, right? And caffeine has to be related to the type of sequence, right? And so then try to get students to tell me, well, what would it look like for caffeine to be related to the type of sequence? Okay, so caffeine is a categorical variable. Type of sequence is a categorical variable. So what kind of graph would we need to look at, right? So I've already talked about stacked bar charts or mosaic plots with my students. And so what would that graph look like if caffeine was in fact related to the type of sequence? Okay, well, it might look something like this, right? So we might have a larger proportion of people who had consumed caffeine on sequence A compared to the proportion who had consumed caffeine on sequence B. Okay, so that's maybe what it might look like for these two variables to be related, right? And so how does that provide an alternative explanation for the observed difference in mean memory score between the two sequences, right? Well, if consuming caffeine helps with memory, we have a higher proportion of people on sequence A who have consumed caffeine, right? So maybe that's one reason why that mean was 9.17 compared to the mean of 8.27 for sequence B, right? And so this is that idea of a confounding variable. Okay, so let's check, right? So let's go back to the multiple variables applet and let's see, right? Is caffeine acting as a confounding variable here? So I'm going to take memory score out of the response box, and now I'm going to put caffeine into the response box, right? And so now we're looking at the two sequence groups and the distribution of caffeine in those two groups, okay? And here's now where it's important, right, for the students to understand and realize that they were randomly assigned to a caffeine or to a sequence. When you clicked into that web page, you were just randomly given one of the two sequences. And so it looks like the random assignment did a pretty good job with creating a similar distribution of caffeine in those two sequence groups. So I'm going to go back to my PowerPoint. Okay, so the purpose of random assignment then is to reduce the possibility of confounding variables. And so how does it do that? Right? So in other words, how does random assignment keep this kind of thing from happening, right? Is what needs to happen in order to prevent caffeine from being a confounder, right? So random assignment needs to keep that relationship from happening. And right, so it could do something like that. Okay. Or something like what we saw in the multiple variables applet with our own data. A lot of times students will think it has to do this. It has to create a 50-50 within each sequence. And that's not true, right? So the proportions of people who did not use caffeine in sequence A and the proportion of people who did use caffeine in sequence A are dependent upon the overall rate of caffeine consumption in the sample, right? So it doesn't have to be 50-50. It could be something like 60-40 or 20-80, right? But just the idea that the distribution here is very similar to the distribution here. And if that's the case, then we know random assignment is kind of doing what it's supposed to do. All right. So random assignment reduces the possibility of potential for confounding variables. It does that by ensuring, hopefully, that the distribution of each unexplained source of variation is similar for the two explanatory variable groups. Okay, so in the case of caffeine, right, hopefully it does something like this. And that means, right, that in a well-designed study that uses random assignment, we can allow for the possibility of a cause and effect conclusion. Okay. So before I go on, let me bring you back over here to the activity. Okay. The last question here, right? Because you're probably thinking, well, what about sleep? For a students in a second course in statistics, I would give them sleep as a homework assignment. So, well, I mean, they need to get more sleep, obviously, but I would encourage, I would have them use the variable amount of sleep. I would give them the data and have them repeat questions 7 and 8 using sleep, right? And sleep is quantitative now. So it's going to be a little bit different. They're not going to be looking at a mosaic plot anymore. They'll be looking at 2 box plots or 2 histograms for each of the sequences, right? But the idea there is that hopefully when they do that, right? The applet kind of froze up on me. If I bring try sleep. Yeah, it's not letting me do it right now. But if you bring sleep into response and caffeine, or sorry, sequence into the subset by box, then I'll reload here. So there's sleep and then by sequence. And now we see, right, that the mean amount of sleep in each of those groups is about the same. Okay. So you guys you're not doing too well. We should be we should be 7 to 8 hours here. What's going on? There's some people doing really good up here. And some other folks you guys need to work on your sleep. So anyway, so I would make that a homework problem that they need to investigate, right? So to kind of circle back, then to the memory study, right? This was the ultimate goal. we want to try to determine whether there's a cause and effect relationship between type of sequence and memory score in the presence of all of this other variability. Okay. The study used random assignment, so hopefully these things over here are not acting as confounders. Okay. But they're still responsible for variation in memory score, right? And so sometimes there's this disconnect, like, well, you told me that there weren't any confounders. There's no confounding variables, right? Or we've reduced at least the possibility of confounding. And students sort of get that confused with removing variability, right? So if we ask students, well, what's the purpose of random assignment? Oftentimes they'll say to remove variability from the response. That's not the case, right? Those things, caffeine, amount of sleep, how good a person is at memorizing, they're still going to cause variation in memory score. It's just that we've dealt with this relationship over here, right? With random assignment. And so that's keeping these things from becoming confounders, right? And so now, right, we're sort of set up to ask the question, could the results we've observed happen by random chance? Okay, so now we're set up for a hypothesis test, okay, two sample t-test or, simulation-based inference, perhaps, to sort of address this question more fully between type of sequence and memory score. So just as some closing thoughts here, last week Beth talked about random sampling, and today we've talked about random assignment, and we know that this is confusing for students, the difference between those two things, right? And so in random sampling, our goal is to obtain a representative sample from the population so that we can generalize results from our study to this population that we took the sample from. In random assignment, our goal is to create groups, treatment groups or explanatory variable groups that are similar with respect to the distribution of extraneous sources of variation, so that we can draw cause and effect conclusions if the data reveal a significant difference in the mean response between the groups or in the proportions for the two groups, whatever type of response variable you're working with. So a couple of links at the end of the talk here. So the second link just gets you to the applets in general. So if you follow that link, where is it at? It takes you to the ISI landing page, which I haven't shown you here. I thought I had. Yeah. So it'll take you to this landing page, and the applets are here. There's a set of applets for the introductory course. There's a set of applets for the intermediate or second course in statistics. The applets for the intermediate course are here, and that was the multiple variables applet that I showed you. But there's also descriptive statistics. You can load the data here into the descriptive statistics applet or a comparing groups applet that you might use in a first course. While I'm here.
You're not sharing that page, Karen?
Oh, I'm not. Sorry, guys. Let me get you back over here. Thank you. So from the memory test page, you can load, which you may have already played with these, you can load the data into descriptive statistics or comparing groups or multiple variables applets. The landing page for the ISI site brings you here, and then there's applets for the intro course and the intermediate course. The intermediate applets include the multiple variables applet. Then also here, you can click into this Google Sheet This actually shows results from every instructor that has ever given the memory test to their students. So the latest results just get appended at the bottom. So you could copy this and save it as a file for your students to access later if you wanted to. And then the first link at the top of the PowerPoint page brings you to this landing page where you can generate a class-specific URL to use for your students. So I just typed in eStars Workshop and then hit generate URL, and it gave me this link, which will be unique then for your class. So you could set up a link for each of your courses or just one for all of your courses together. But maybe since your courses would be at different times of day, maybe it's good to generate one for each course. But then you can post this on a Canvas page or something like that to share it with your students. And then you have access to get back to that data when you need it. So I'll stop there. I think it's almost 1 o'clock, so I don't know if there's any questions or I can answer for people.
There's a question in the chat. Go
Yeah,
ahead.
I saw that. So there's a question about, this is everything that I've shown you is descriptive. And so it is in some ways up to students' discretion whether they believe the differences in means or the differences in medians are big enough for that variable to be responsible for explaining variation. And so, I tell my students at this point, it's kind of a judgment call, right? But if you're seeing any differences at all in those means, then that variable might be explaining a little bit of variability, right? But obviously, the further apart those means or medians are, the more variation that variable is explaining, right? So just trying maybe to have them think about there's a continuum of how much variation is getting explained. And I think in that last question in activity 1, where you can show region and education level side by side, right? They can see, oh yeah, region's not really explaining that much. Those means and medians are closer together from group to group, and those within group standard deviations are bigger, right, than what we saw with education level. So
Thank you very much, Karen. Another
okay.
question or two, comments? It's almost it is the top of the hour in case you need to be somewhere. But perhaps Karen can stay a few extra minutes if there are questions.
Yeah.
Next week, same time, we'll have another session like this. The topic next week will be comparing two proportions. The presenter will be Laura Callis from Curry College in the Boston area. Another question for Karen? There's a question about assessment and grading in the chat, Karen.
Yeah. So I actually don't grade activities. I present the activities kind of as part of their notes for the course, and like the sleep variable, I would put that into a homework assignment and have them investigate sleep as a confounder on a homework assignment. And then certainly I would revisit these types of ideas and graphs on a quiz or an exam. So, maybe give them sort of a similar situation between perhaps taking notes on a computer versus taking notes on, handwritten, and give them an exam question to investigate that instead of sequences, provide some data, have them, investigate confounding variables and random assignment and that sort of thing, sources of variation in a new context. But I don't actually grade the activities. Yeah. So again, primarily through quizzes online, I'll provide feedback or auto-generated feedback on these ideas, and then through homework assignments and exams. So the activity, so as you saw, we did both activities in about an hour. I would not do both of these in the same course period. The first activity, maybe 20 minutes. The second memory activity would probably take the entire 50 minutes with the students, and we might even carry over a little bit into a following day on that activity, because I would want the students to actually be using the applet and answering some of these questions independently or in small groups. And then we would come back together and talk about, some of the questions together as a whole class. So yes, I do release the completed activities and the solutions for my students. So I post them on Canvas. So
More questions? Feel free to unmute or type in the chat. Last call for questions for Karen. See a question from Henry in the chat. What about students' interaction?
yeah,
I'm not sure. Go ahead, Karen.
Yeah, I'm not quite sure what you mean there, but in my classes, I generally try to get discussion going in small groups. And I also then try to have them interacting with me. So I'll do, some of these activities where I'm asking questions of the whole class, and hopefully people are responding. And then I also will put them into either pairs or small groups. I'm usually in a bring your own device situation, and have them work through the activities together in a group. So sometimes, I guess going back to a previous question, sometimes I do have them at least submit the Google Doc that their team has filled out. But most of the time, I don't do that. I just circulate around the room and answer questions and pose questions. So yeah, at Cal Poly, our classes are small, 35. We're capped at 35 unless we take an overload. So sometimes we can get bigger sections of 70 or so. And I wouldn't hesitate to do this in a class that's bigger. So, but I don't have any experience trying it. So I'm sure there's people in the audience who do have experience trying it in larger lectures. Yeah, and Stat 2 is we're running multiple sections of Stat 2 now, each of our quarters, and those are capped at 35 as well.
Last call for questions. Thanks again to Karen. Thanks to all of you for coming. Please come next week, same time, same Zoom.